right, so today we're going to look at, it is section A4. So in your book, A is the appendix. So this is a section from the back of the book. It has, the back of the book has a review of different topics, okay? And that's kind of what this is. It's a review of how you do complex arithmetic. So yesterday we learned that complex numbers have two parts to them. They have a real part, which is what you studied in Algebra 1, and then they also have an imaginary part. When you write a complex number like that, real part first, and then it could be a plus or a minus, depends. And then you put the imaginary part second. That is called standard form. Okay, so when you're asked to write a number in standard form, that's the order they want it in. Real part first, imaginary part second. So looking at our kind of example up above, in 2 plus 3i, what would be the real part of 2 plus 3i? The 2, just the 2. Yep. And what would be the imaginary part?
3.
Just the 3, yeah. So the I is just there to tell you what's in front of it is the imaginary part. Okay, so that has a real part of 2, and it has an imaginary part of 3. Okay, any question on that? Now, we're going to talk a little bit more about what is that? Okay. Well, that's kind of a broad question. Depends what the context of your question is. So if I asked you in that context, what is I? What would you tell me? Yeah.
It's like a variable.
Okay, so a lot of times in algebra, you pick a letter. We use the Greek alphabet. Sometimes we use the English alphabet. Depends. But a lot of times a letter is a variable. In this case, that letter is not a variable. It's not a variable. If I wrote this down, and I asked you what that is, what, not mathematically, but what is that? What is it?
Pi.
Pi. Okay. What does that mean? What do you like? Apple pie? What's pi?
So
Like what is like? It's this. That's how you write it. Pi. But what is pi? Yeah.
I can't remember. Isn't it like the circumference of a circle?
Well, you're thinking mathematically. I mean, kind of in general. Like that inherently doesn't have to be connected with math. It's something though. Yep.
It's a value.
What do you mean?
Like it stands for something but only one thing. So it's
Okay, we're going to talk about that after. That's once you connect it to math. But not connecting it to math, what is it? Yeah.
A Greek letter?
Yes, that is just a Greek letter. That's all it is. It's a letter and it's a Greek letter. Now, in math, we connect that letter with something. Okay? What is that letter associated with in math? So what's the meaning of this now, like in the context of looking at it from math? It's not just a Greek letter anymore. Yeah?
It's both like the circumference of a circle and like a number that never really ends.
All right, it has something to do with the circumference of a circle. Can you be more specific? Yep.
a really large number.
What number?
3.14.
Yeah. So it's, when we write pi in math, it is a Greek letter, but in math, we don't use that as a letter. It stands for the number 3.1415926, and it keeps going. Right? So it stands for that. So if you had to do a word problem in math, and you had to pick a variable because you didn't know. A lot of times you might pick X or you pick Y. You would never use this to represent a variable in math. Right? Even though it is a letter, it is a Greek letter. And a lot of times we use Greek letters when we don't know angles in a triangle. You might use like alpha or beta. But you would never label one of these angles as pi. If you put a pi there, in math, that means you're saying this angle is 3.14. You're not saying that it's a variable. Okay? You never use that as a variable in math. Okay? Same thing with I. In math, if you had to pick a letter to represent something you didn't know in a word problem, you could pick X, you could pick Y, you could pick Q, you could pick all kinds of letters. But I is not a letter you should pick. Because in math, I stands for something. It stands for something just like pi stands for something. It stands for that number. That's what I is. It's the square root of -1. And the reason we have to pick a symbol to represent it is because if you try to take that in on your calculator, it doesn't, let's see, go like this. It won't work. If I do square root -1, it says it's a non-real answer. That means if you look at all the symbols we have to write numbers, those are all the digits you're allowed to use when you are writing a number, 0 through 9. You can have decimal points, you can put two together to make a bigger number, like a 12, right? But those are all the symbols you're allowed to use when you write numbers. There's no symbol in that circle that could ever represent the answer to the square root of -1. There is no symbol that looks like that. So they had to use something different to represent this answer. And they chose to pick I. That's the symbol. And sometimes they borrow letters from the Greek alphabet, but for this one they borrowed it from the English alphabet. So now, if you basically teach the calculator Algebra 2 by allowing it to use not just real numbers, but imaginary, and I type in the same thing, it doesn't tell me that the answer is non-real anymore. It actually gives me the answer. And the answer is the number I. So in our lesson, I is a number. What number? That number, the square root of -1. And why don't we write it with one of these numbers? Because you can't. You cannot write that answer using that system of numbers. It does not work. So that's why when I showed you that diagram, imaginaries were their own separate box. They don't fit into these kinds of numbers. So when you are writing complex numbers, sometimes it has a real part and an imaginary part, like that. 2 plus 3i has both. If you write down a number and it does not have a real part, like 4i, think of the real part as 0. 0 plus 4i. That's called a pure imaginary number. Generally, you will not see the 0 part. They're not going to write that. They're going to do that. Okay. So a complex number with no real part is called a pure imaginary number. Okay. Any question on that? So let's look at how we add complex numbers together. When you add complex numbers, you can kind of think of it as combining like terms. So let's say these are two complex numbers. What's the real part of the first one? A. What's the real part of the second one?
C.
C. If you want to combine those complex numbers together, the first thing you can do is you can combine the real part in the first one with the real part in the second one. They're both real. So they can be combined together. And then if we look at the second part, we have a number with I right there, the B, and we have another number with I right there, D. Well, we can also add the B and the D together, but the I has to stay there because B and D were imaginary when they were separate. They're still imaginary when we combine them. It's kind of like if you combine X's with X's, they're still X's when you combine them. You just have more of them now. Okay. So you can combine real with real and imaginary with imaginary. And that's it. Okay? Your answers are going to end up looking something like that first problem that I showed you. You can't add 2 plus 3i together. They're not like terms. Okay? There's nothing you can do. So don't try to write like 5i. If you had this, yes, that is 5i. That's all you can do. Okay, so let's try that one. So we have 3 plus 8i, and we're going to add to it 8 plus 2i. When I combine those together, what's going to be the real part of my answer? Yeah. 11. Real, real. The operation is addition. 3 plus 8 gives us 11. Try to make your ones and your i's look different. Otherwise, if you go back and look at your work, you're going to get confused. What's an I and what's a 1? Okay, so we got 11. And what about when I add the imaginary parts? Yeah? 10 I. So we have 8 i's, we have 2 i's, and we're going to add them together. 8i plus 2i, 10i. And that's the final answer. 11 plus 10i. Okay. Any question on that? So earlier I told you that I always represents the square root of -1. I'm going to write that down. But you would never see your answer written like this. 11 plus 10 times the square root of -1. That's really what your answer is. But they never write it as square root -1. They always use the symbol for it, which is I. Okay. But technically that's not wrong. It's just kind of a weird way to write it. All right, let's try this one. We have 4 minus 2i plus 3 minus 8i. What's going to be the real part when we combine these together? 7. You get a real part of 4. You get a real part of 3. 4 and 3 added together, it's going to give you 7. How about the imaginary part?
-2.
Yeah. -2, -8, and the operation is addition. -2 plus -8 is -10, and what do we have to put next to it? I. Yeah. And that's that one. Okay, let's try one more with addition. -3 minus 4i plus -7 plus 8i. What's going to be our real part when we combine those?
-10.
Yep, so that's -4
4 plus 4i.
So -3 plus -7 is -10, and -4 plus 8 is 4i. Yep. Okay. So any question on adding complex numbers? Okay, so it's pretty straightforward. Now with subtracting, it's pretty much the same idea, except instead of adding this real part to that real part, you're going to subtract them. So it's A minus the C And then we have to do b minus d. Okay, so it's exactly the same formula except minus and a minus inside the parentheses. So think of that as being distributed out. That's how subtraction works. Okay, I always stays right next to whatever you get when you do the b minus d. All right, so let's try this one. So we got 4 plus 12i minus 3 plus 4i. Okay. What's going to be the real part when we subtract those two?
1.
Yeah. You have a real part of 4, you have a real part of 3, and the operation is subtraction. 4 minus 3, that gives you 1. And the imaginary part, 12i, 4i, and you're subtracting the 4i. So what do we get?
8.
Yep, 8i. That's it. So you get 1 plus 8i. Any questions on that? Right, how about 2b? For a second, when you do that out, what your real part is and what your imaginary part is. Yeah.
Real part would be 5.
Real part would be -5.
Oh, minus 8. Yeah.
So 3 minus 8.
Yeah.
And what about your imaginary part? Yeah.
1i.
1i, because it's -5 minus minus 6. Minus a minus becomes a plus, just like with regular real numbers. Okay, so that's adding and subtracting. Any questions on those two? Next is multiplying. Oh yeah, but before we do multiplying, I need to explain to you about I again. So I told you that earlier. I equals the square root of -1. And that's a definition. I can't prove to you why. It's like proving why octagons have 8 sides. I don't know. It's just the prefix oct means 8. I don't know why they chose OCT to mean 8, but it does. Same thing with, like, if you said, why do parallel lines never cross? Well, they never cross because the definition of parallel means you don't cross. So it's a definition. Same with that. Why did they pick I to be the square root of -1? I don't know. You could have picked a different symbol. I mean, they could have used X, or they could have used another Greek letter, like they chose pi to equal 3.14. Well, that's what somebody chose. And it gets confusing if we change it now, so we all have to stick with using the letter I. So now, if we know that I is the square root of -1, we should be able to figure this out. I to the second power. I is the square root of -1. So I squared means to take the square root of -1 and square it. What happens when you square and square root something? They cancel out, and what are you left with? You're left with -1. Okay. And that is important because when we do multiplication, which is the next thing, we're going to end up with I squared quite a bit. Anytime you end up with I squared in a problem, you have to change I squared to -1. If you don't, it's not simplified. Okay, so that one's it's a little different because you started with an imaginary number, you raised it to a power, and the I disappeared. You don't have that's not an imaginary number, that's a real number. So that is one of the times where you do arithmetic with imaginary numbers and the imaginary part cancels itself out. That usually doesn't happen. Like if you do subtraction with imaginary numbers, if you started with real and imaginary, a lot of times you end with real and imaginary. The i's don't just disappear. Only way they could is if you had a 12 and then a negative 12. Then they could cancel out. Right. Any question on that? Okay. Okay, so just recapping what we just said. I equals the square root of negative 1. Why? Because. We're based on that, we just figured out that I squared is negative 1. So anytime that you do arithmetic, do not leave I squared in the final answer. Generally, when you are adding and subtracting, you're not going to have to worry about I squared. It's when you multiply and divide, which is what we're doing right now. So how does multiply and divide complex numbers work? It's basically, it's like the distributive property. Just like you learned in Algebra 1. You had something like this. If you want to multiply those two things together, because there's two terms in each parenthesis, you have to multiply like this. Okay. Some people remember that as FOIL. Some people just call it the distributive property twice, double distributive property. But however you remember it, that's what you need to do. Multiply the first, then the outer, then the inner, and then the last two. And it's when you multiply the last two together. The last term has an I here, the last term has an I here. When you multiply an I with an I, you get an I squared. So let's try an example of multiplying that out. Everybody have the description part? Let's try this one. So we want to multiply 2 plus I times 1 minus I. Okay. First thing we're going to do is that. What's 2 times 1? 2. Okay. Next thing we're going to do is 2 times negative I. That's just like doing 2 times negative x. Now I know I said to you I is it's not used as a letter here. It's used to represent the square root of negative 1. But you're still going to do it exactly like you would do this problem. So what do you think 2 times negative I is? Negative 2i. Then you do your inner. What's 1 times I?
I.
It's just I. And now we have to do the last. Well, let's start with, it's a positive times a negative. What's a positive times a negative?
Negative.
That's a negative. And now you have to do I times I. What's I times I?
I squared.
I squared, just like doing x times x. Okay, so that I kind of color coded each part for you. Okay, so now we've got some like terms. Negative 2i plus 1i. What's negative 2i plus 1i?
Negative I.
So that's negative I minus, and we just said what this is. This minus I just copied down right there. But what's I squared?
Negative 1.
Negative 1. So we've got 2 minus I. What's minus minus 1? Plus 1. And now we have one last step. There's two terms there we can combine together. What are the two terms that are left you can put together? Yeah. What's a positive 2 and a positive 1? 3, and the minus I stays right there. That's how you multiply two complex numbers together. All right, we'll try one more, but any question on that one? Let's look at this one. 8 plus I and 3 plus I. This time, can somebody just tell me what's the first product you're going to do?
24.
8 and 3. Okay, so I heard 24. Yep. What's the next thing you multiply? 8 times I. All right. What's the next one we're going to do? Yep, the I and the 3, and that gives me 3I. And the last one we need to do is positive I times positive I. Well, positive times positive is positive. And what's I times I? I squared. Okay. So we get 24. What do we get when we combine like terms?
11.
I get 11I. And I squared is going to turn into what number? Right, so I'm not going to do plus -1. I'm just going to say -1. Okay. Once you change that, you've got one more pair of like terms to put together to get your final answer. What is the final answer here? 23 plus 11I. Yep. All right. So any questions on multiplying? All right. So that brings us to the last thing, which is dividing. In order to divide, you have to know how to multiply. That's how you do it. And there's one thing I have to show you before we divide, which is what's called the conjugate. Okay, we're gonna need to use this thing called the conjugate when we divide complex numbers. So first of all, the symbol that you're going to see in the book for the word conjugate, since they don't like to write out long things in math, they take the letter and they put a bar above it. When they put a bar above the letter, that stands for conjugate of what's underneath it. So that gives you the symbol for it, but it doesn't really tell you what the conjugate means. What the conjugate is when you take this symbol right here and make it the opposite of what it is. That's called the conjugate. So if you had a problem like 3 plus 9i, the conjugate is 3 minus 9i. I'm not saying they're the same number. No, they're not. They're different numbers. But if that's the original, that's called the conjugate. Now, if the original already had a negative here, then when you do the conjugate, it would change to a positive. You just change the sign of the symbol in front of the imaginary part. You don't do anything to the 3. The 3 stays as a 3. Okay, so to find the conjugate of a complex number, the fancy word that you can say for that is to negate the imaginary part. Negate means make it the opposite of what it is now. Okay, so I've got a chart. We'll look at some complex numbers, and then we'll look at their conjugates. Let's start with 3 plus 4i. What do you think the conjugate of 3 plus 4i is? Yeah?
3 minus 4i.
3 minus 4i. Yep. All right. How about the conjugate of negative 8 minus 2i? Yeah.
Negative 8 plus 2i.
Negative 8 plus 2i. How about the conjugate of 5i? Yeah.
Negative 5i.
Negative 5i. Yep. If it's confusing because there's no real part, then think of it as like 0 plus 5i. The conjugate is 0 minus 5i. It's negative 5i. And how about 3? What's the conjugate of 3? Yep.
Just 3.
Just 3. Doesn't change. Again, why doesn't that one change? Well, think of it as 3 plus. 3 plus, there's no imaginary part. 3 plus 0i. The conjugate is 3 minus 0i. Well, plus 0 minus 0, same thing. Okay. So any question on, if I give you a number, how you find the conjugate of it? Okay. So what do we use the conjugate for? We use it when we do division. Okay. The big problem that we run into with division is you are not allowed to leave an I in the bottom. Just like we don't leave square roots in the bottom. So we have to fix that. The way that we're going to fix having an I in the bottom, and we're going to get rid of it, is with that. We're going to use the conjugate. And that's going to get rid of it for us. When you divide two complex numbers, notice the first thing it says is you multiply, right? You don't actually do division, you multiply. What you do is you multiply the top and the bottom of your fraction by the conjugate of what's in the bottom. So to divide two complex numbers, multiply the top and the bottom. So yeah, it's like two multiplication problems you have to do. Multiply top and bottom by the conjugate of what's in the bottom. Not the conjugate of what's in the top, the conjugate of what's in the bottom. Let's try this one. This one's not as bad as this one. This one has a real part and an imaginary part in the top. This one only has a real part in the top. So the distributive property in the top is going to be easier in this problem. Okay, so based on what I have written right above it, what are you going to multiply the top and the bottom by?
3 minus 4i.
Multiply top and bottom by the conjugate of 3 plus 4i. Now let's do the top, because that part's easy. In the top, all you're doing is distributing a 1. That's, first of all, it's distributing a 1. That doesn't even do anything. Second of all, it's just a single distributive property. That's all you have to do with it. If it was a 2 or something like that, it would change it. But 1 times 3 is still 3. 1 times negative 4i, still negative 4i. Now let's do the bottom. Okay. First thing we have to do is 3 times 3, which gives me 9. Okay. Now watch what's going to happen here. I told you all the i's are going to go away. Right? They have to, because that's how you do division. What's 3 times negative 4i?
Negative 12i.
That's a negative 12i. What's 3 times positive 4i?
12i.
Positive 12i. Negative 12i, positive 12i. Every time you multiply conjugates together, those two things will always cancel each other out. That's how it works. And the last part, 4i times negative 4i. Well, what's a positive times a negative?
Negative.
It's going to be a negative, so start with that. And we have 4i times 4i. We already took care of the negative.
16i squared.
That's a 16i squared. Okay, so it's 3 minus 4i. 9 minus. I squared is next to 16, but we need to change that. What does I squared turn into?
Negative.
Negative 1. Okay. So now we've got 3 minus 4i. And we've got a negative 16 times a negative 1. That's a positive 16. Negative 16 times negative 1 turns into positive 16. And we have to combine like terms in the bottom. What's 9 plus 16?
25.
25. And now that's not standard form. Okay, standard form is when you have the real part in that box, plus or a minus, and then the imaginary in that box. So what we have to do is just separate this into two fractions. So write each number in the top over 25 separate. So the real part is 3/25, and then we have a minus sign because we had a minus sign there. And the imaginary part is 4/25. That's how you write the final answer in standard form. Okay. Any question on that? Okay. Let's try one more of those. Okay, this one in the top, a little bit more annoying than the bottom, but it's still going to follow the same thing. You are going to have to do distributive property in both parts now. What are we going to multiply the top and the bottom by to start this whole thing off? Yep.
5 plus 12i.
5 plus 12i. Now, when you start to get faster at these, I can already tell you what the bottom is going to come out to. It's 169. Right? It follows a certain pattern when you multiply this times that. Okay, but we don't have to learn any shortcuts if it's confusing. You basically just square this number, you square that number, 25 plus 144, and that's your answer. But if that's too much to think about, let's just multiply it out. And when you do it, you get 5 times 5. And now you're going to have 5 times 12i, which is how much?
60i.
That's 60i. And 5 times negative 12i.
Negative 60i.
So those cancel. 60i, negative 60i. We don't even need to worry about that part. What's a negative times a positive?
Negative.
A negative. And what's 12i times 12i?
144i squared.
144i squared. And we'll come back to that, and you'll see how I got 169 in a second. Now in the top, 1 times 5. What's 1 times 12i? 12i. And what's 5 times 4i? So we have a 12i and a 20i. That's going to combine and give me how much?
32i.
32i. Yeah, I like to kind of combine it as I go if I can. That way I don't have to keep rewriting the problem. More times I rewrite it, more times I could copy something wrong. Okay, and the last part, 4i times 12i.
48 I squared.
That's a 48i squared. Now, when you do this, you are going to be left with an I in the top. That's fine. But you should not be left with an I in the bottom. Okay. I squared, I'm just going to put it above it, is negative 1. What's 48 times negative 1? So that's really 5 plus 32i minus 48. And we just said this, I squared is negative 1. What's negative 144 times negative 1? Positive 144. Now, when you add the two numbers in the bottom, what's 25 plus 144?
169.
That's how I had gotten the 169. Okay, and 5 take away 48. It's going to give me, or think of 48 take away 5, and then just make it negative.
Negative 43.
So negative 43 plus 32i. So what's the real part of this number?
Negative 43.
Over
169.
169. That's the real. Plus, what's going to go in front of the I?
32 over 169.
32 over 169. And it's always going to ask for standard form. So if you get this far, you're like 95% of the way there. You just separate it. Okay. Any questions on that? So last thing. So this is the last section for the week. So between today and whatever time we have tomorrow, we'll finish up 5.3. But we don't do all of 5.3. So if you look in the book, there are some things I'm going to skip. All right. So we just talked about complex numbers. Complex numbers like that. The first thing that we look at in 5.3 is how we can graph that number. Well, if you can graph the coordinate 2, 3, then you can graph 2 plus 3i. It's exactly the same idea. When you graph a complex number, you use what's called the complex plane. It looks just like an xy axis. It's not an xy axis. It's an ri axis. The horizontal axis is renamed real, and the imaginary axis is renamed, the vertical axis is renamed imaginary. So r and I take the place of x and y. So if I wanted to graph the point 2 plus 3i, okay, the way that I would graph it is I would say, okay, the real part is 2, the imaginary part is 3. So I go to 2 on the real, and I go to 3 on the imaginary. And that's all there is to graphing the point 2 plus 3i. That's it. All right, let's try that. How would you graph 4 minus 8i? Yep.
Go over 4 to the right. So I go down
4 to the right and down 8. That's it. That's point 4 minus 8i. And there'll be a couple of those on the test. You'll just click where you want to put the point, and then you drag it anywhere. If you put it in the wrong spot, you can drag it somewhere else. How about negative 8? How would we graph that one? Yeah.
8 to the left. And
Yep.
just stay on line.
Yep, so we just go 8 to the left. This time, think of the imaginary part as being 0, so you don't go up and down at all. And how about 5i? Yeah.
You just go up 5.
Yeah, we just go up 5. Okay, we just go up 5. That's it. That's all there is to graphing points. Now, if you switch it, it would be wrong. You can't go right 5. It has to be up 5. Right? Right 5 would be different. Okay. Any question on that? All right, and then let's see. This is the last thing. What's this? All right, so yeah, there's only one slide left, so we'll finish this up, and that'll be a good place to stop. So we've looked at complex numbers written like that. When you write a complex number in that form, that is called standard form. It's also called rectangular form. Okay, same thing. Now, I know we normally use A and B when we represent complex numbers, but I think now that we're starting to graph them, it'll probably make more sense if I use X and Y. And I think it'll make it easier to remember. This is the left and right when you graph. Y is the up and down, because you're used to those letters. Okay, so I'm going to switch to using X and Y. And I know normally you put I after the Y. I put it before the Y. It doesn't really make a difference, but I'm trying to match what I'm doing with what's in your book. That's why I put the I before. All right, so this is just a complex number that looks exactly like one of those. Real part, imaginary part. That's rectangular form. Okay. What I want to do is look at how we can write a complex number in polar. And the nice thing about writing a complex number in polar, you already learned everything you need to do it earlier in the week. So we talked about regular polar numbers. I think we did it yesterday. Okay. We didn't do anything with imaginary when we talked about polar. Now we are. When you want to take X and change it into polar, does anybody remember what the formula was for X? It was something with a trig function theta.
R cosine theta.
Yep. So I'm not going to go through that whole thing again, but we proved yesterday using a triangle that if you want to change the X value to polar, you use R cosine theta. And what if you want to change the Y value? Yep.
R sine theta.
You do R sine theta. So all you have to do to change a complex number to polar is take, and instead of writing X, fill in R cosine theta for X. And instead of writing Y, fill in R sine theta. So you're going to fill in the same two formulas you already know. And when you do that, it's going to look like this. That goes right there. R cosine theta plus the I stays right where it is. You're not plugging in anything for the I, but you're going to plug that in for the Y. R sine theta. Now, if you look at each part of that in front of the trig function, they both have something in common. What is it they both have in common? say, yeah.
They're both being multiplied by r.
They're both being multiplied by r. When two things are multiplied by the same thing, you don't have to write it twice. You can just write it once, but put it in front of it. So when you want to write a complex number in trig form, instead of distributing out the r to this and to that, they just put the r in front of the whole thing and put it in parentheses. That way you only have to write the r one time in front. If you distribute it out, you would have r cosine theta, and then you'd have r with the I sine theta, just like we have right there. Okay, but that's how you write a complex number in what we call polar form. It's also called trig form. So that's polar form. That's standard form or rectangular form. And the other nice thing about this formula, there's two things you have to find, r and theta. You find those exactly the way we did yesterday. Anybody remember what theorem we used yesterday to find r? Yeah? Yep, you're going to use Pythagorean theorem, no change there. And does anybody remember what trig function you had to use to find theta? Yep.
Tangent.
And specifically, what kind of tangent? Inverse tangent, yep. Inverse tangent of y over x. So the two formulas for r and theta, it's exactly what you did yesterday. All right, so let's finish up trying to write this in polar. Writing this complex number in polar would be exactly the same as writing that in polar. There's really no difference how you do the work. That's the kind of problem you would have had on Tuesday. There's no imaginaries in that. Just a root 3 and a negative 1. This is a root 3 and a negative 1i. Okay. So, first thing you have to do when you write something in polar is graph your point so you know the quadrant. Because depending on the quadrant, it's either inverse tangent y over x, or what do you sometimes have to add to it? Sometimes you have to add 180 if you're in quadrants 2 and 3. Yeah, 2 and 3. Okay, so let's graph that. That's why I just showed you how to graph complex numbers and see what quadrant we're in. Okay, this doesn't have to be a perfect sketch. We're not sketching it here to sketch it. We're sketching it here to figure out the quadrant. Okay. Positive root 3 and negative 1i. What quadrant is that in? 4. Yep. We're going to go right and down. Positive, negative. I don't care exactly. I mean, I went down too much, but again, it's right and it's down. It's quadrant 4. When you're in quadrant 4, do you have to add 180? No. So your angle is the inverse tangent of, what's the order of the letters? What goes on top? Y. That's your y. The y is always, if I go back here somewhere, the y is always what's with the I. I think they rhyme. Y, I. And what's my x in this case? Nope, not 3. Root 3. So negative 1 is my y, and root 3 is my x. It's exactly like you would do from yesterday. Okay, so let's get our angle. And let's do it in degrees. So I'm in radians, I don't want radians. So second inverse tangent, negative 1 over square root 3. Yeah, not like that. Second inverse tangent, negative 1 divided by So that gives me an angle of negative 30. Okay, negative 30 is going that way. How much would it be going the other way?
Maybe 330.
330. The directions here didn't say to use a negative or a positive angle, so we can use the negative, that's fine. But they may ask you to write it as a positive in the homework or on the test. But I'll leave that. So negative 30. And the formula for my radius. R squared equals, and what two numbers am I going to fill in those boxes?
Square root of 3 squared.
Yep.
And negative 1 squared.
Negative 1 squared. What's the square root of 3 squared? 3. What's negative 1 squared? 1. 3 plus 1 gives me 4. And if r squared is 4, that means r would equal,
16.
well, we're not squaring it again, we're square rooting it.
Sorry,
2, yeah, good. There you go. So there's your radius, there's your angle. Take this number circled in red, take that number circled in red, and plug them into this formula right there, and stop. That's all you do, you stop. So it's r cosine negative 30 plus I sine negative 30. That is the final answer. And if you're like, why don't you do that out? Well, if you distribute it out and you do it all out, you're going to change what's in that green box all the way back to what you started with. So we don't, if we wanted to check it, we could do that, but we don't want to do it out. That's the final answer. Yeah.
Would our y be 1 instead of negative 1? Because I is negative 1, so wouldn't it be minus negative 1?
Well, the negative goes with the number that's in front.
Oh, okay.
Yeah, so the negative goes with the number. It wouldn't really matter when you're finding the radius, because when you square it, this negative just cancels out anyway. But it is important to make sure you use the negative here. If you forget that negative, you would get positive 30 instead of negative 30. So you get the angle wrong, but you'd still get the radius right if you forgot it. Okay. Any questions on that? All right, so I think we've pretty much finished everything up. So tomorrow will be a good day. We can spend time reviewing everything we need to. That's going to be on the test. All right, so let me. Okay, so homework for tonight is what's circled, or what I put a box around in black. Tomorrow night's homework will be the page 333, 11 to 19, but you don't have to do this one tonight. Okay? Just what's in the black box.